Hello everyone, hope you are doing good and welcome back to my channel. Today we are at Geeks problem of the day 30 for December month, and we have a easy level question in front of us. So let's see what the question is. It's winner of an election, and as you can see, it's the name, as the name mentions, the question answer is also on this only. There is an election, there are some candidates. We have to find out who has the maximum number of vote. But yeah, there are some more things here. They are also asking us to lexicographically sort based on names if they have similar votes. We'll see all that, but let's see what are the inputs first. They are giving us a number n, which is going to be the length of the array, which is the second input. In this array you are going to get the votes. Basically, that is the first, let us say, voter voted for John, the second voter voted for Johnny, and so on, right? Something like that. Ultimately we'll have to count how many votes each of the contestants got, and then you will have to decide who are the ones who have the maximum number of votes. Let us say two people have, or more than two, let us say more than one people have the same number of votes. That is the maximum number of votes. In that case we will have to sort it lexicographically. Okay, so we will have to output the name which is lexicographically smaller than the one than others, right? As simple as that. Okay, so that was something which I mentioned, but let's see what exactly they have given an array of n names. Okay, of these are the name of candidates in the election, where each name is a string of lowercase characters. Okay, a candidate name in the array represents a vote casted to the candidate. Okay, print the name of the candidate that receive maximum count of votes. If there is a draw between two candidates, then print the lexicographically smaller name. We will try to understand what it means. First, let us code all the above details. Okay, let us code first of all the above details. Then we will come to what is lexicographically smaller, and that is it. And so they have given a nice example here. That is, in this particular example, you will see that John and Johnny, okay, both of them have that is maximum number of votes. That is four. Okay, in this case, four is the maximum number of votes, and John and Johnny. Okay, let me quickly zoom in and show you. John and Johnny have the maximum number of votes. Now, if you try to understand what is this lexicographically smaller concept, see, lexicographically basic. The if you Google it, the basic meaning of this is that alphabetical order. Okay, as simple as that. So we will compare this alphabetically. Okay, that is the first point of difference. Which string is lexicographically smaller? That is at the first point of difference. Uh, which one has the a smaller character in the alphabet? Okay, for example, see, john and john are same here. Okay, but it has a y extra. Okay, it does not have anything. Let us say it has a. Okay, then also it will be smaller than that of y. Okay, as similar as that. That is as the first point of difference. Which one is smaller when we see the ordering in the alphabet? Okay, as simple as that. So in this case, John is smaller, that's why John is preferred. We will again come to this, but how to implement this in Python, I will tell you that. But let us code the other details first. Okay, so this is my code. Basically, I am as you might be if you're following me, you might be aware of this, that this is some of the data structure which I usually use. This is called a dictionary data structure in Python. In other languages we call it as a map. Okay, so yeah, this I'm using. And then for each candidate, okay, that is for each element in this ARR. Okay, this ARR, what I'm doing is, see, first of all, each element in this ARR is a name. Okay, who are contesting the elections. That's why I use the name candidate. Okay, so for each of those candidates, what we are going to do, I will check if the candidate was already voted. That is, see, poll is a dictionary, right? It will have a key and value pair. So in the key place, we are using the candidate names, and in the value place, we will be storing the number of votes they got. Okay, so this is what I'm doing through this. Okay, that is, if the candidate is getting the vote for the first time, make a key entry and allot the value 1. If the the particular candidate already has an entry in the poll, then simply increment its vote count by 1. As simple as that. Okay, then I'm just printing it for your reference. Let me quickly run and show you how it looks. So yeah, this is how it looks basically. So you can see that John has 4 votes, Johnny has 4 votes, Jackie has 2, and Jamie has 3. Okay, this is how it looks. Okay, I will quickly comment it out because otherwise the answer won't be accepted. Then I'm after once I've come out of this, that means I will have every candidate's name and also the vote each of them has got. Okay, then I'm trying to find out what is the maximum votes. Okay, because remember, if you see the sample input output, you also have to output the maximum number of votes. Okay, so it's all about that. So what I'm going through the values in my poll dictionary, only through the values, not through the keys, and I'm finding out the maximum value. Okay, as simple as that. Once I have that, I am storing it in the variable called max votes. Okay, then I'm creating array called winners, because see, as they have mentioned, If two, or that is if more than one person has got the maximum number of votes, in that case we will have to sort it lexicographically. The one who has the lexicographical smaller name will be declared as the winner, and we will have to print his name in the output. Okay, so what I'm doing for that, see, I'm creating a winners array, then I'm going through each of the key and value pairs in the polls dictionary. Okay, I'm checking if j is the equal to maximum number of votes. Remember, this is because we are going through the keys and values in the poll dictionary. This will be the name of the candidate, this will be the vote he has got. Okay, so I'm checking if j is equal to the max votes. That is, we already know that the max votes in this particular scenario is this. Okay, that's being stored here. So we are checking if this is the case, then the corresponding candidate is also a, among the winners. It could be a winner, right? So I'm simply appending his name to the winners. Okay, to the winners array. Then I'm doing a sort operation. Remember, in Python, if you're not passing any key and basically you are sorting strings, in that case they will be by default sorted in lexicographical order. Okay, this is what I wanted to show you. In Python, it is very easy. You don't have to pass anything. If you don't pass any separate key and you are trying to sort strings, then in that case they will be automatically sorted using the lexicographical order. Let me quickly print this and show you. Okay, so we already know that John and Johnny are the winners, but how, let us see this particular sort is working here. As you can see, John is getting the zero. That is the way Python is saying it to us, is that John is lexicographically smaller than Johnny. As simple as that. Okay, because at the first point of difference, okay, you will see that see JOHN is here, JOHN is here as well. Okay, there is additional characters here, N and Y. In this case, N and Y are there. In this case, nothing is there. So though nothing is there, but still you can say that it is safe to assume that John is lexicography smaller than Johnny. Remember, if at the end of John, let us say there is a okay, JOHN A. In that case, also JOHN A will be smaller than JOHN Y, because remember, when you talk of lexicographically smaller, we are talking about at the first point of difference, which of the strings is having a character which is much smaller than the other character when we compare their order in the alphabetical sequence. Okay, as simple as that. That's what it is. So yeah, friend, that was it. And once we have sorted the winners array, the winners of zero will be the name which is lexicography smaller than the others. Okay, so I'm just printing it for your reference. I will just comment it out. And yeah, this is the winners of zero, and this is the maximum vote that he has got. Okay, so I'm returning it in a tuple. Okay, this is called a tuple in Python. Okay, this the brackets which you are seeing here is called a tuple. Okay, I'm writing in a tuple form because if you see the code here, they are also doing the same. Okay, once we have written the results, they are also uh, simply taking it and printing it. Okay, results of zero, results of one. That's why I have written it in this way. Okay, with if you change the language, maybe you will have to written it in a different way. That's what it is. So yeah, friends, I will just quickly run and show you if it works. As you can see, we are getting the expected results. I will give you the solution. You can segment it for your own, and you can see it works clearly and it works perfectly. Okay. So, often that was all. The new concept which we learned today is that lexicographically smaller. Okay. In Python, by default, if you don't pass any key for the sorting, it will automatically take the lexicographically one. The sorting will be automatically done based on the lexicographical order. Okay. As simple as that. So, often that was all for today. See you tomorrow. Thanks a lot.